vertical axis and you simply screw it round 360 degrees. There's very little load on it. Where you're going to get a lot of load, if you do a loop, that'll be like 3.5 G, guaranteed. Because what you're doing is you're flying along, you sort of pitch down, get your speed up to about 120, 130, and then woof, and up we go. And there's a lot of G-force on you, the plane and on yourself at the time.
How do you calculate the, like, when you're like, for instance, doing a loop, you calculated the same thing, like?
Well, no, when I've done loops, I've normally been in aerobatic planes and they've got a G meter inside.
Okay.
That's how I know what sort of G you call.
So, what?
Hey, you done in the sim?
What? Yeah, I think.
How did that go? Good?
Yeah, good.
Sim still work?
Yeah, still. What?
Okay, now, as you can see from this, the more weight we are putting on the aircraft through load factor, the more weight the wing needs to support, correct? How does the wing support additional weight? Added angle of attack, increased angle of attack. So we, regardless of what speed we're flying at, if we put enough load factor on the aircraft, the plane is going to stop. Because you're going to be pulling back all the way to the stop, and the load factor is still overcoming the weight that the wing can produce. I mean, look, 70 degrees, let's say that's 75-degree angle of bank, easily doable. We are putting 4G. That means that 2,300 multiplied by 4, 9,200 pounds, that wing needs to support at 4G. Right? That is a hell of a lot of lift this thing needs to produce in order not to go down. And the only way we can have a wing produce 9,200 pounds, well, we can do two ways. We can double the airspeed, that way we get 4 times the amount of lift, or we have to increase the angle of attack. Okay? But to increase, if we're flying in level flight, it means the wing is producing 2,300 pounds. All of a sudden, we need 9,200 pounds. That is a hell of a lot of pullback on the ocean. To give you a rough idea, at 60 knots in the summer, if I want to do a 60 knot angle of bank, the plane will be practically on the on the stall warning, even though I'm doing about 90, 95 knots. It'll be it's about to stall, and that's like 2G. So you can imagine, you're running out of lift. You really are. The other effect that the load factor has, stall speed. How does it affect the stall speed? Guys?
Increase stall speed.
Why?
Because the weight of the center of gravity is shifting.
No.
Because you increase the critical angle of attack.
You don't increase the critical angle of attack. The critical angle of attack is the point where the aircraft stalls, or the wing stalls, and that's always the same. Well, the more we're banking, the more lift we need. Yeah. In order to bank and produce more lift, we need to increase the angle of attack. Yeah. So the more we increase it, the closer we are to the critical angle of attack. Yeah? We can actually calculate it. How? Somebody tell me.
There's if I draw the diagram, I can get it, sir.
Look at diagram, man. Sorry. Square root of the load factor. If we're at 2G at 60 degrees angle of bank, what is the square root of 2? 1.41. So if our stall speed is 60, indicated airspeed, at 60 degree angle of bank, it will be 60 multiplied by 1.41, which would be about 84 knots.
Yeah.
Okay, that's how you calculate your increase in stall speed. What is the square root of 3? 1.8, something like that? Anybody? You got to calculate, somebody? Don't worry, the calories you burn, I'll replace